Hey guys, I just wanted to make another little video. I know we got cut off early a minute ago, but the point that we need to get across here is that we have a signal, a 0 to 10 volt signal. We're calling that our analog signal to our analog input. But that 0 to 10 volt signal is being converted to bits inside this PLC, right? That card is converting that to bits. The program sees it as bits, and that 0 is the same as 0 bits. The 32,767 is the same as 10 volts. So all that is, there's nothing special going on. We've got our little potentiometer right here. As we turn the dial, we're changing the voltage signal going to that card. It varies between 0 and 10 volts, according on the resistance change of this potentiometer. So if we know that the 0 to 10 volt change in our program, we're scaling it down, we're telling it to be 100%, and we're moving that scaled down value, or actually right here on this program, we're taking our divided value so we can only go to 50%. And we know that anytime we do this, we can always pull up these output tag files and input tag files. We can look at that value right there as this changes. Okay, we see right there I just changed the value, which I turned it wide open to 32,767, but our output's only half of that. And if we go to binary, you can see the full word. In binary, that's only 16,384, but let's say we move it a little bit. Our binary changes just like the decimal does, but we're using the decimal number. It's cut because it's easier for us to work with in this analog circuit. We can do the same thing for our input tag file. We can look at our raw data in our input tag file, convert that over to decimal. See our values change. So pretty much all we're doing, 10 volt signal, converting it over to 16-bit word, which is 32,767 in decimal format, and we're using that number to power output. If you got any questions, just send me an email or reply to the assignment that we're going to be having, and I hope this clears some things up and helps some people.